As the presenter this morning emailed us, he's still in London, England, not London, Ohio, and so that was going to make presenting here difficult. So Tom has a presentation he threw together that he's going to give us on modern times, specifically around passwords. So give it up for Tom.
Now this one usually runs a little short, and I know you're all just absolutely hating me because need to stay away from that cake. So passwords. First, I'm Tom. I look fancy. I've got websites, Twitter, Google+, whatever. I also walk around a lot, so that camera's probably not going to follow me. If you want to get a hold of me, I'm everywhere across the internet. So, in essence, the password, it's old. How long have we been using passwords? Yeah. I mean, you can go back to the speakeasies, you can go back even before that. The guy knocks on the door, whoa, what's the password? Bubbles. All right, you're in. He lets them into the bar, and you'll have a good time. But we've learned a lot, right? We can't just use bubbles as the password. That's simply not good enough, especially not when we can guess 1,000 passwords a second on the slow end. So here are the bad guys. Here are the things that we have to watch out for. Here's the things that are trying to make our world more insecure or more inconvenient. Probably the biggest, the most common is a word list attack. You saw Dave Kennedy take a look at certain passwords, certain user behaviors, and how he's trying to use education to fix those. We'll go into that a little bit later. But if you teach people to use really bad passwords, like the name of their dog plus the year, or the season plus the year, it's a really bad password. What a word list attack does, for those who don't know, is it takes the most commonly used passwords, puts them at the front of the list, and it says, okay, we're going to try those first. We're just going to run through the list, and you'll get about half of them in most organizations. The next thing is, and it's not really commonly used unless you're trying to crack something that you've stolen locally, is a brute force attack. You literally just run through every combination of characters that could possibly exist for a given language and hope you crack something. Very slow. You never use it in an actual attack per se if you're doing something remote. It's just too slow, too noisy. Common account attacks. This is getting more common in the internet. If you use the same password for Twitter that you use for your Exchange admin, you're going to have a bad day. When LinkedIn leaks your password and it happens to be your domain admin account, it's game over at that point. You shouldn't really reuse passwords, but we keep telling people this, but they keep doing it. And that's kind of our fault. I'll go into some of the things that people in IT do. People like me, people like my organization, say, oh, you're going to have all these characters, and it's got to be this long, and people will make one really good password that hits the majority of their sites, and they'll use it for everything. It's bad, but it's our fault that they're doing it. Forgetting passwords. Here's something that people don't really think of as part of your standard set of bad guys. If people are forgetting their passwords, they're going to make simpler ones, plain and simple. They're going to make ones easier to remember. They're going to have passwords.doc on their desktop, or they're going to be scribbling sticky notes all over the place. Check under the keyboard. It's always under the keyboard. Always. The things that make a good password, we've got entropy, which is jumbling up characters. It's the randomness inherent in a password. If your password is ABCD, it's pretty easy to make a program to enumerate that to get the password easily. If it's got more entropy, it's going to be harder to crack. And it's all pretty easy stuff, but we'll get into the better stuff in a bit. And one other thing, I don't really like to just sit up here and be a talking head. Please interrupt me. I like having a conversation more than I do just talking. Length is definitely the most important thing when it comes to passwords. And we're starting to see organizations value length over complexity, over certain rule sets, and even take away password rules as the password gets longer. It's a really novel concept and actually leads to much happier users and much better passwords, way better security. And again, uniqueness. Don't reuse passwords. It's just a bad idea. So here are some brute force times at a relatively modest 1,000 guesses per second. This is assuming, no lockouts, no compensating control. If you just have a slow network connection and you're attacking a system, this is what it would take to guess these passwords. Now, here's some cool stuff. Because you use different characters, you've got 9 possible characters, or 10 possible characters if you're using just numbers, right? So the list of possible passwords is a lot shorter than if you include letters, and then uppercase, and symbols. And it just keeps getting bigger the bigger your rule set is. So, yes?
For the listing of all those times, does that factor in any common passwords, or does it just assume no password is common?
No, this is just straight up, really dumb brute forcing. There's no intelligence at all in this list. As you can see in the bottom 2 examples, just by adding one more character, you can make a password way harder to brute force. But it's not about brute forcing, right? So someone tell me, and raise your hands, which of these is more secure? Which of these passwords?
Well, it considers whose reference you're using. The bottom one's obviously more complex, but like I told you in past presentations, the only company I wasn't able to break into was a company where all their employees had 3-character passwords because I didn't think anyone was that stupid.
Exactly. So again, one more character makes your attacks way more difficult. You don't need complexity for security. You just don't. The general gist of this presentation is more of a look at the social component, the human component, the squishy component of security, how we can make the humans better at what humans do well, not a lot, but make them a little better at what they do poorly. People won't remember this. If you say, well, my password's the name of my dog and I just hit 0 9 times, okay. All right, that's okay. That's way better because you're not writing down a password. You're not going to use it for Twitter and Facebook and your email account and your work email account and all this other stuff. So here's a couple things. This is what we tell people to do. We tell them to use a password manager. We tell them to log into LastPass or 1Password or KeyPass or whatever. Anything on earth just to make something long, complex. Just don't use your mother's maiden name as your password, anything. And then this is what they do. Everyone does this, right? So how many people work IT or InfoSec? Probably, yeah. The majority of the room, right? How many times do you see that password? Probably a fair amount. Some combination of something and then some numbers. I mean, it's a basic, it's the default word list in everything. If somebody says, hey, let's make a word list and crack some passwords, you start with word, then some numbers. That's how you build a word list. That's rule number 1. That password doesn't hold up over time. Here's what users do. And this is all of our faults. So, of course, the first one, common word, some numbers. The second one is really, really common. As Daryl likes to point out, you all can change your passwords to summer 2014 because we're now officially in summer. So prepare yourselves for fall 2014. I probably shouldn't say this on camera. My company, half of the people use this password because I haven't been able to break them yet. It's bad. It's really bad. And it's all our fault because we say, hey, you've got to have something that's at least 10 characters long. You've got to have capitals. You've got to have numbers. And you have to change it every 90 days. Oh, well, that's convenient. Or you have to change it every month. Well, just use the month. I know people that every month it's, August 2013, and then their first name. That's the password. And this happens a lot. Do you guys see this? Am I the only one who sees this? Everyone's seen it, right?
Yes, definitely.
So a couple other common ones, and the third example isn't horrible, it's bad. But it's not the worst thing I've seen. At least they've got some punctuation in there. And of course, the bottom, it's abysmal. I see that a lot. I see user initials plus some numerical version of year plus month. That happens a ton. We did this. And a lot of government organizations mandate password changes to comply with various regulations, and that's a real damn shame. We are causing bad security practices by forcing people to not just choose a really good password from the get-go and say, yeah, you can stick with it. Have that one, be done. I'm also the VPN admin at my company. We've got RSA tokens. They all need a PIN. They say, do I have to change this every month? I say, no. Choose one that's 6 characters long, and I won't even look twice at it. You will never have to change it as long as I'm in charge of this. They pick something crazy complex. They don't pick their birthday. I mean, I run the system. I know what they pick. Because RSA isn't very good at obfuscating user data. But they pick something that's, to me, seemingly random. To them, memorable, complex. They'll use it. And it's 2 factors, so the risk is pretty far mitigated that way. And this is pretty controversial. Forced password changes decrease security. They don't do anything. They don't help anyone, ever. Except in one very tiny, tiny case. If a piece of malware gets on your system and it's using a password, and it needs to use your password for a very long, extended period of time, that's when a forced password change would really affect anything. But you basically got, if you get a piece of malware, if you get an attacker who's trying to compromise your system, and he gets your password, is he going to be like, yep, got that password. Now I've got 90 days to kick back. No. No, he's going to take your password, he's going to root your company, he's going to get on your domain server, he's going to wreak havoc, he's going to take all your data instantly. He's not going to sit around and wait because he knows, well, I've got, maybe 60 days, maybe 60 whole days to use this password. This is great. Now he's going to get his work done real quick. Malware is going to get its work done real quick. The only thing forcing people to change their password does is it forces them to make really, really bad passwords. Like these. Horrible, awful passwords. Because it fits in so nicely. It hits all the complexity rules. It gets IT off your back. It lets you get some damn work done. And you can apply it every single password change. Because it always works. That's terrible. We shouldn't do that. So what can we do, right? We do the only thing that makes sense. And it's really hard to do, right? You can't do this in straight up Active Directory. You've got to have some add-on somewhere. In Linux, you can do anything. But in Active Directory being a little bit harder to extend, you've got to have a custom module. Great passwords shouldn't expire. Well, what makes a great password? And yeah, some people are throwing things at me at this talk, so thank you for not. But what do you guys think?
Passwords suck.
Well, yeah.
You should use a passphrase.
Yes.
Upper Unicode characters. You can't actually type.
Yes.
Yeah, Windows, you need to probably want to At least 15 characters to avoid landman, hash tracking.
Anyone else? No?
You're
Yes?
trying to secure a binary octal bit with anything is laughable.
I don't believe that you use Unicode characters. PHP doesn't parse Unicode the same way it does ASCII.
I think we can discount that advice because PHP. I'm just kidding. I also write PHP. I understand your pain. It's awful.
Unfortunately, for compliance, there's some where it doesn't matter until the government or whoever regulates this compliance changes their mind.
Right, which means it'll never happen. Right? The government compliance is never going to change. The Earth can get hit by a meteor.
You don't have government compliance, but they think that's a good idea.
As best practices, we don't have PCI, but we're going to do PCI as best practices. Those kind of people would never deal with any of this stuff.
Yeah. Well, it's a good thing that Target implemented PCI.
Right? Yeah. They did a great job.
They did a great job.
Totally saved everyone a lot of hell. All of you have seen this. This is very common. This is going around the internet. It's the famous XKCD, the correct horse battery staple, and where Randall Monroe points out very lovingly that the only thing we've done in InfoSec and in IT security policy is we've made people choose passwords that are easy for computers to guess and hard for humans to remember. That's what we've accomplished. The good news is we can fix that. It's not impossible. We just have to change our thinking a little bit. Correct horse battery stable isn't a bad password. I wouldn't use that exact one. I'm sure it's on plenty of ordinance right
That's
now.
inside my dictionary.
But it's not bad. I mean, from a password standpoint, that's actually pretty good. The moral of the story is longer is better, always.
That's what she said.
It is. We should be listening, right? Longer is always better.
In the case of, they include discussion of Unicode, what about white characters?
We could do this.
Sure. Tab is a great key.
I don't know any word list that has Unicode characters in it aside from other languages. But passphrases. Passphrases, and I'm defining passphrases as a password that's greater than 16 characters in length. Now, just to see what type of reaction you would get, go up to, your CTO, go up to upper management, go to someone in sales and say, yeah, we're thinking about making passwords 16 characters long. You will either be laughed out of the building or thrown out of the building. One of the two will happen. I recently tried to implement this new policy in my company, and it was a combination of the two. They were laughing and throwing. Still trying, very difficult. But people assume the worst. People assume, okay, so you've got to have a Hebrew word, 37 characters, a couple Unicode characters, spaces, wide characters, and some form of book that this weird author wrote in your password. And people always assume the worst. The thing people can start making when you have really long passwords is they can make correct horse battery stable in all lowercase. If they add spaces, that's even better, but they don't have to. And we need to start making rules that take this into account. Now, other places are starting to do this, most notably Stanford. And it's not only Stanford. Stanford made the news, but there was actually a university that did this before them, a couple of them. So we're starting to see this in education. This made the news because Stanford is giant. This is their password rules, all wrapped up in a nice, neat infographic. It's got to be at least 8 characters. You can't go below that. But if you make something that's 20 or more characters, don't even worry about capital letters. They don't care. The complexity rules, the requirements for a password, shrink as the password gets longer. Because when you're looking at word lists, when you're looking at brute force tools, when you're in the 8 to 11 character range, having a good word list, a really good word list, can still sync a password. It's difficult with all of those sets, but it's not impossible. For 20 plus characters, as long as you stay away from common phrases, common song lyrics, and Bible verses, then you can do that. That's one of the things, one of the pieces of analysis that's been done after this change happened is they said, hey, just about everyone is using some form of Bible verse or Beatles song. Those are going to start hitting word lists, and we have to stop that. So as long as you have a block list in place, it makes for a good password. Again, if you use the word monkey, it's on a word list, it's going to be the first one hit. If you use it's been a hard day's night as your passphrase, it's going to be on a word list, it's going to be hit.
There's a thing with that too, Tom. I mean, when you have passwords that 8 to 15 characters, 8 to 11 characters, the size of dictionary that you need to enumerate all possibilities is much larger than the size of a dictionary for something that's 20 characters.
Oh yeah. I've downloaded 10 character rainbow tables. And it wasn't the most fun download I've ever had.
Oh no, a couple hours, but
Yeah.
still, I mean, it's a huge difference. I think I had a dictionary that was like 13 gigs. I don't remember what all it covered, but I believe it went up to 16 characters. Again, not all possibilities, but still 13 gigs. If I had a dictionary that covered 20 characters plus, we're talking like peta to epobytes.
Yeah. And God forbid they throw in a capital letter in that.
Exactly, that's a lot of storage.
It really, and we can't lie. Passwords, we can't just keep doing this. We are going in circles. Yes?
I found that I've worked in some places that require users to have these 16-digit passwords. And in doing so, what it allowed was the user created their password, and when they signed in, to the workstation, it automatically punched the clock. And what I found was, hey, regular expressions are out of the circle. You're opening yourself up to different attack vectors by, and it's not necessarily anything new, but it's a new way of thinking about how I can implement this item.
That's a good point to consider.
Well, that, and on top of that, if you have a 20 plus character password and you think, oh, if it's more than 20 characters, then it's just going to be either, a string of characters or just a string of words. Instead of guessing ABC, you're guessing correct apple, correct baby, correct whatever, what have you, instead of conventional brute force. I mean, where do we go from there?
Right. And there's no secret to it. The password, by implementing these rules, we are just pushing the wheel further a little bit. We're going to have the exact same problems going forward. Because storage gets cheaper, network gets faster, processor gets faster. We're not solving any problems. This is a way to push the problem down the road a little bit. There are people who are interested in solving the password problem. This doesn't solve any of that. And it's true. People are going to write word lists. There are going to be different attacks based on having giant passwords, right? Because there's a lot of rule complexity to it. There's a decent amount of processing to it.
There's a lot of analysis on it right now, too.
Yes.
A lot of people who analyze the statistics of the passwords that are actually getting hit, the different words inside of those.
Yeah. Word lists will be built. I mean, this is not immune to a word list attack. If they're constructed well, it hurts it, and it makes it more annoying for a wordless attack to happen. But as we know in security, especially security at scale, the objective is not to be invincible, because you'll never accomplish that. The objective is to make yourself the smallest target possible. And if someone says, oh man, 20 character word list? Dude, no. I'm just going to hit the 16s. We're done with that. Or I'm going to hit the 8 character passwords.
So far, you've talked in terms of the length, and I think the assumption is that one could repeat a brute force as often as one wished. So, second characteristic then would be you have a rule about timeouts after failure. And then the third principle would be, do you have access to the hash? And so if you have access to the hash, then it's only a matter of how long under these new high-powered CPUs it takes to build a rainbow table or to generate one on the fly. So I forgot what the stats from the earlier speaker was.
93.2 billion. 93.2 billion per second. So,
Well, does that turn into a 10-character rainbow table? Is that approximately what that turns into?
Well, keep in mind, rainbow tables get pretty gigantic after 12 characters with your full set. Now,
That's the point I'm making, is that your table earlier was very small.
yes.
So if the number of characters, the number of characters per second, could you generate a 10-character rainbow table in 24 hours, for example?
It'd be worth a look at for sure.
If so, then you don't even need the storage to hold it.
Right, right. You just run through it. You don't even care about storing the values because you can enumerate it fast enough.
So to me, if you're going to make your point about keeping passwords simple, you have to assume that the hash is not available.
Right.
And that's an entirely different topic as well.
Yeah, this is
protecting those things.
I know, but if the hash is readily available, then none of this makes any difference.
well, so as far as an attacker obtaining a copy of your password database or getting a list of hashes, the only thing, this doesn't make any difference. You're entirely right. This doesn't help that attack at all. It doesn't mitigate anything. It might make it a little bit more annoying for a little bit longer, but not very much. At least not enough. It wouldn't stop anyone, right? The only thing that will prevent that attack is by using a secure hashing algorithm to store your passwords. Password-based key derivation function, bcrypt, for instance. So I got a list of MD5 passwords, not even salted, just straight up MD5. Just like, this is fun. Threw them into a rainbow table and got it back, done. I also got a list of bcrypt passwords. And I said, all right. So I tasked out a machine on Amazon EC2 to go crack those. I let it run for 24 hours, ended up with one password out of 1,000. As long as you do, in that attack, as long as the technology implements a secure hashing algorithm, there's not a lot you have to worry about. There's still some, because if they're trying to crack one password, especially if that person has reused a password and that service is using a really bad hashing algorithm, they can reuse it. So as long as all services start implementing secure hashing algorithms, it minimizes the attack vector by a huge amount. bcrypt is one of the ones that you can't serialize. That even if you throw GPU power at it, it doesn't do a whole lot to speed things up. It does a little bit, but not on the level that you would see in SHA or MD5 or hash algorithms built for speed instead of built for security. So yeah, but you're right.
So if you want to take the hashing piece off the table for a minute, then the next most important thing is the timeout after failure.
Yes.
And once you put that on the table, then what we ought to be calculating is if it's a 10-second or however long timeout, 10-minute, how long would it take to brute force a rainbow table brute force a 6-character password? Right.
And that's why we have this slide. And then the next one, but this one first. Account lockouts are often used to dissuade brute force attacks, and it does work, but a lot of IT organizations deploy or set their account lockout rules incorrectly. This means if a person, if their password, if you have a proxy and it uses user credentials to log in to get people to the internet, fairly common. When a person's password expires, Windows says, hey, log out, log back in. You need to change your password. And they're just like, oh, whatever, and they click the X, and then they try to Google something, and they just keep hitting refresh because the thing won't come up because the proxy's got the wrong credentials, and they just locked out their account. We could avoid that by, I mean, hopefully they wouldn't hit refresh 30 or 50 times. They might. But setting a lockout of, say, 30 to 50 incorrect attempts. I do. Well, so in the cases, in your case, if
made brute force possible across the entire environment, because I don't know how many employees you got, but the more employees you got with 30 to 40 attempts, and you probably have so many tries in a given minute, those thresholds are easy to discover. So I could easily go against a couple of counts, figure out what the lockout is.
I think I've got the answer to that in a further slide.
And then I can build my entire brute force attack, fall underneath your stats, and basically sit there and run forever and a day.
It might not be the right answer. I think I've got the answer to that in another slide.
I'm going to DOS your lockout and refresh it. That's what I'm going to do. So I'm going to call that server to reset and then go back out.
Well, I mean, if your servers are randomly rebooting in a production environment, you should probably know what's going on. That's just me. That's coming from a sysadmin point of view. If my server randomly reboots, I'm not just going to go, well, if I'm server rebooted randomly in the middle
Good,
of
it's
the
about
day.
damn time the thing was going slow
So your
anyway.
goal here is to goal to set some level of security, but yet present some kind of lockout issue in your environment.
Exactly.
That's where your problem's at.
Yeah. In most organizations, set this way too low. I get the idea. I think this is a better solution, right? And that's the solution to your issue, but most places don't do that. And you can only implement this if you've got some sort of
I
scanning.
know no one ever watches the log. I know that's reality. What they need to do is set up auditing, automated auditing of that
Right.
stuff, so they get alerts based on the type of triggers.
Exactly. And that's,
Not look at the logs.
Yeah, you set a quota.
And
Yeah.
the denial of service would just be the serving service itself, not like they would serve.
okay.
You should still see that. If you're a sysadmin, you see your things fail like that.
Right. It's still pretty noisy, and if they've got a monitoring system on the back end, it's probably setting off some alarms. Now, depending on the organization, they might not have one, and they might not care.
I'm interested in hearing the rest of your solution here.
Yeah. So my thinking is lockouts, yeah, we can have them, set to 30 seconds, set to a minute, to try to dissuade brute force attacks. Why not just slow things down progressively? Why not say, hey, look, you get 5, 10 tries at a password, and then you've got to wait 10 seconds before you try another one. You get 5 more incorrect, okay, we'll just add 30 seconds. And then you escalate from there, up to a point, right? You don't want to lock someone out for eternity and say, well, you've got to wait the next 60 years to log into your account. But I think this is better than an account lockout, especially if there's a user interface element present to tell the user, hey, you can't do that, you're doing it too much.
How and where do you set that?
It's custom modules. You can't do it in straight Active Directory. It annoys me.
You can use a service called faildan.
Yes. I use that on my Linux systems a lot. I haven't implemented it in Windows.
Even then, what about, as far as the amount of time reaching a, whatever you're storing that value, reaching the maximum value of that type.
And so reaching the maximum value of the lockout time?
No, I mean, lockout time increasing to the point where it can't increase any further.
Oh, yeah. Well, you would set that something unreasonably high, right? So if you had to wait 30 minutes to throw another password to your brute force engine, it would probably stop things mostly dead, depending on scale.
Because what I'm saying is, I mean, having, with that, it opens into potentially someone just, again, just making that limit increase so high, so fast.
You could definitely DDoS a
that
user.
you could,
Yeah, you could prevent someone from logging in if that was the goal. But your question,
I was saying, I'm looking at it from WPS authentication.
hmm,
You know, where you're just dealing with a router, and then, you know, a home user is probably not gonna recognize a smack their router, and then reboots all of a sudden.
Yeah. No, that's true. That's true. And this really only works in an enterprise environment or in an environment where you've got monitoring, you've got a sec team, you've got an ops team, you've got an IT team watching these things. For a home user, you know, they've got nothing. I mean, you could yank someone's internet connection for half a day and they might call Time Warner, maybe. They might wait for it to come back and they might unplug the router 6 times.
I didn't know that you were strictly speaking from the corporate standpoint.
Yeah, I should have made that clear. Yeah, this doesn't, I still think longer passwords are good, but disabling account lockout universally probably isn't the best idea.
But if they had, if the users, like, if they locked out and then the user themselves had a way to re-enable it, you know, like a secondary login.
Right.
Through their email, which is, you know, on a different service.
Or they have, I know for Rails applications, the general perceived best practice is through a gem called devise. And if your account gets locked out or timed out, you can click something similar to a reset password link and it gives you a one-time auth code that's good for an hour. And then you click that and it says, okay, you're clear to log in now, please put in your password. So something like that would alleviate that issue. But I think slowing things down is probably the better answer. I think it would be more effective and less disruptive than lockout. And that's really the whole point, is to make it hurt password attacks without necessarily hurting a user who's just dumb. Because we have those, they exist. And none of this means anything without some sort of monitoring tool, without a bunch of interns watching logs, without some sort of red flag, like enterprise style red alert thing going off, saying, hey, someone's doing something and a bunch of accounts are trying to get accessed rapidly. You should probably look at this. You should probably unplug your Ethernet cables. If you don't do that, if there is no account lockout, if you're not even slowing things down, it's worthless. I mean, you probably should be owned at that point.
So you're gonna put interns watching your logs?
Hmm.
Are you gonna put interns watching your logs?
The way I see it, there's enough interns in the world that you could just take like a team of like 120 interns and say, here, watch this screen as stuff scrolls by, and they'll catch enough.
I haven't usually seen a whole lot of use of this coming from this on that area.
One thing this doesn't help, you could have a slow burn brute force attack. I don't know if anyone's going to really be that persistent, but if someone's persistent enough to hit your box every 30 minutes or every hour trying to get a password out of it, they're going to be really persistent. There's not a lot you can do to stop that. You can lock out accounts, but they're just going to try again after you unlock them.
So the default Active Directory event viewer one settings, it only displays when accounts get locked out. You have to actually crank up the default setting, crank up the log level to be able to view failed logons too.
Yes. So yeah, basically, passphrases, better, longer is going to be better, and way more important than being complex. Longer is always better in just about anything. Monitoring tools, watch your logs, get some like red alert stuff going. You need to be alerted when your network is under attack. That's, plain and simple. A lot of people don't, a lot of companies don't, but if they're standing up in an enterprise environment, they should be qualified and vigilant enough to run it, or else Daryl will own them. Fail to ban, account lockout, really nasty account lockout where you say you can get your password wrong twice and then you're locked out until you call IT, who's in India, and by the way, they're asleep now, is expensive for people. Make lockout easier, either by introducing just delays, introducing short lockout periods, anything that'll make your users not hate you, but it'll still dissuade brute force attacks. I think delaying does that.
Or you could not have the staff in a country.
Well,
No,
let's be realistic.
Charles for president. I'm not saying policy, but I'm just saying, I mean, if they're really that bad and they're.
You'd be surprised. I've seen some things.
I know the mechanics behind that particular thing, and it's beyond the scope of this presentation, but you get what I'm getting. I'm just saying.
So with fail to ban, does that give you the ability to set delays? Okay, is it?
I need to look at fail to ban specifically.
It does.
Okay.
I use it in enterprise environment. It does.
Okay.
The really old BMS systems used to have a time delay that was actually semi-random. I mean, you would get a period from anywhere to 3 to 5 minutes added on progressively more. But what was nice about that is you could put in the absolute correct password and it would totally ignore you. You wouldn't know that was correct if you did it during that time period.
A lot of web services are implementing delays when you try to get an account, a single account tries to log in too much. It says, yeah, you've got to wait. And then if you keep getting it wrong, the timer gets increasingly large. Especially in web services, you rarely see strict lockouts. You usually see it with banks, healthcare, especially social networks or anything that's not really important data. You don't see account lockout, you see these delays. But monitoring tools are important.
So in addition to delays, you're also seeing more and more, especially with cloud services, sort of capture challenges after somebody fails login attempts. In lieu of like a delay, just that extra challenge that would stop a brute force from working.
It depends. There's a lot of great tools that solve really great captchas. And anytime a new captcha comes out or a new style, you'll get tools written specifically to attack those. Now, luckily, the tools leak, and then you can use them to do good things with reading, like translate books or read off addresses or whatever. But it's the same cat and mouse game you have with antivirus. Somebody builds a better captcha, somebody's going to build a better captcha reader. In the end, everyone benefits, but we're still fighting the same war. Any questions?
Back on obtaining the password hash. Where do we stand on that? Is it difficult to get a hashed password?
It all depends on the environment and what you're trying to attack. There are some, if you're attacking a Windows environment, essentially if you're on the local box, you can get whatever local credentials are on the box. Windows is trivial to pull credentials from. Same with Linux, OS X. If you are a process on the machine, you can get the local credentials for that machine. There are ways to mitigate that, but not by default.
That was part of Dave's talk earlier. He got a box, but he didn't have any admin credentials, so he had to help desk sign in, so now he did have admin credentials.
And then once it was in memory, it was accessible.
And as far as web services, it depends on the service, how it's implemented, what it's written in. Early PHP apps, if you go back 5 years ago, 10 years ago, early PHP apps that had a MySQL backend, it was really easy because no one sanitized their inputs because no one cared. PHP makes it really easy to develop web applications. It's fantastic. The downside of that is you get a lot of people who shouldn't be building web applications now building web applications. So instead of putting in a username, they can now put in just a piece of a database query to pull database information out, or add a user, or drop all the information, what have you.
Little Bobby tables.
Yes, little Bobby tables.
I love it.
What about, and
Back to the example of having access to the box. On a workstation, that's essentially going to limit you to the password of the user of that workstation. But if it's a server, obviously, even if it's in using Active Directory, anyone who comes in through that server is vulnerable to collecting their hash.
More or less. Daryl would probably be more qualified to answer that question than I would.
Well, and for Windows, you don't even necessarily have to crack the hash. You can pass the hash data, or
Right.
you can use tokens. So if domain admin is logged, it's one of the reasons Dave had them log in. You can use the token that was logged in. So
You have administrative access to the box
So
or the server. Yeah, you can go ahead. If you're administrative access to the machine or the server, there's a number of tools available. One, you can pull the hashes off out of the box that are set on the box. You can pull the tokens, the delegation tokens that can be replayed from the box. The other things you can do, there's WC Windows Credential Editor. You can run that on the box and it'll actually strip anyone who's authenticated under the box's passwords out of memory. Or if you've exploited, you can also run Minicats on that box, which will also pull those same passwords out of plain text, whether they're Kerberos or not, all out of the system in plain text, if the person's authenticated.
But that all assumes admin privilege, though, right?
Yes.
I was trying to come from the ground up. If I had someone's hash through a less privileged method, then automatically the rainbow table gives me access within a matter of minutes to that password. So
If you have the hashes, the LM hash, the Intel M hash.
right, in a Windows environment.
In the Windows environment. LM hash can drop out pretty quick unless you have a decent cracker. A person has a good complex password. You may not be able to easily crack the Intel M hash. But if you have the hash, there's really no need to crack them. You can replay those hashes.
So it seems to me that the weakest link here is, can I obtain a hash without admin privilege?
Sure. Yeah. There's lots of exploits that do that.
Apart from being on my box.
Right. There's lots of exploits to do privilege escalation, where you take a standard user account and you can get certain additional privileges to be able to try to access things you're not supposed to. But yeah, that's one of the things you would go after as an attacker.
You're going to have to be system to get those hashes. We say administrator, but actually your system on that machine. So if you compromise the system process on a machine, then you can pull all the hashes associated with that machine, or gain access to the critical memory areas on that machine using plain text password. If you just have a hash, one of the typical attacks, so I compromised the machine on an assessment last week, and we had a guy's hash. He was not a domain admin hash, he was an Active Directory hash, but we want to elevate our rights within the environment. Having an individual user's hash will give us access to his resources only. So we quickly replayed that hash back against the entire Windows, all the machines on the Windows environment, making specifically requests to $C$ and looking to try to retrieve a specific file, Windows system 32 cmd.exe. By playing that attack specifically, looking for that, knowing that through that method we'd be able to identify what machines that person would have administrative access to, and just administrative access, because that's what we need. We played that back. This guy turned out to be a developer. We were able to gain access in an environment that had 2,000 machines. We were able to gain access to 50 machines that he had admin access to as a developer. We gained footholds to each one of those as administrator, turned around and used the tool Minicats to pull all the passwords out of memory on all 52 machines. And by doing that, we were able to compromise 6 domain admin accounts. So it's a matter of It's an influence, spread the influence, escalate data, spread the influence,
So
escalate
does
data.
two-factor on your domain server stop that?
What was that, two-factor authentication?
You have two-factor authentication on your domain servers that hold the hash tables. Does that stop what you just mentioned?
It will stop some stuff. I have yet to encounter anyone with two-factor, but I have discussed that topic with other people. The two-factor authentication will stop certain levels of access. Typically, that level of access is being stopped is going to be RDP. So I'm not going to be able to RDP to that box, but I can still make SMB requests to that box and not be challenged. Since I can make SMB requests to that box as an admin level, bypass an RDP interface, I can easily escalate that box right from that box also. That's what I understand on how it functions, but I have not done it because I have not encountered it. And if they did, I didn't pay attention to it because I rarely go to RDP. I just go to RDP just to screw it and take pictures of the report.
Anyone else? Cool, that's it.
Thank you, Tom.